sense. So I did quick double check and we are good. Make sure you count all your oxygens from all your sources because you end up with, 28 oxygens on both sides and 18 hydrogens on both sides and everything, but it does balance out. We are good with this one, right? So we look at the next one. It is a base redox reaction now. We haven't done a base one as a group together. Base ones, the book has several different ways to do it. I believe your book has several different ways to do it. There are several different ways to do it. The way that I think makes the most sense for first, early chemistry students, clear up to this is how I do it, is I just pretend it's in an acid. I just say, you know what, I'm in charge here. I'm going to pretend it's in an acid. Then when I'm done, I say, wait a minute, I was pretending it's in an acid, and it's not in an acid, it's in a base. So everything that's got an H plus, I just neutralize with an OH minus. And then I do some canceling at the end, right? So it's actually pretty easy. So I'm going to balance it like it's in an acid. Then at the end, come back and add hydroxides for everything that that's an H plus. And if I add to one side, I have to do the same to the other side. Right, so let's just try that, right? I believe I've written this one down right. This one comes from number 31. The aluminum and the permanganate ion go to manganese dioxide and aluminum. This is a complex ion, right? Tetrahydroxy aluminum ion, I think is how you would name that. I get a little rusty on my complex ion naming. Anyway, we'll balance out our oxygens with water. So 4 H2Os over here, because there are 4 of those. Balance out my hydrogens. There are 8 oxygens here and only 4 here. So plus 4 more H pluses over here. At the end, we're going to have to come back and deal with the fact that we've got these H pluses here. Right now, I'm just ignoring them. Here, I'm good here. My oxygens, I need 2 more waters over here, which means I need 4 H pluses over here. Then we go to figure our charges. I have aluminum with a 0 charge here, aluminum with a +3 charge here. So we must have 3 electrons. We have a -8 and an overall -1, so that's +7. Hopefully you've done enough of these balancing ones. You just kind of recognize permanganate as a +7. Here we've got a -4, so manganese is a +4. Manganese is goofy. It can do all kinds of different charges. So then we go 4, 7 is our difference. So we must have 3 electrons on this side, 3 electrons on the top, 3 electrons on the bottom. So those just cancel out. So I get to just start canceling out other things. So I'm going to cancel out everything before I worry about my hydroxide base stuff. So my 4 H pluses cancel out here, and those they don't matter anyway. So we're going to definitely have to do another one. Then some of my waters cancel out. So I end up with 2 waters over here. And that's all we had to do for that one, right? Pretty straightforward. This bottom reaction, I've got 2 chlorines and only 1 chlorine. So I'll start by putting a 2 here. That gives me 2 oxygens. So I better fix my 2 oxygens by putting 2 waters over here. If I put 2 waters over here, that's going to give me 4 H pluses over here. That's not a plus sign. What's wrong? I've been in quarantine too long. Lose it. So 4 H pluses over here. Now we figure charges. This has got a 0 charge. This has a -2, so a +1, right? Because overall we're -1. There are 2 of those. So that means we've got a 2 electron issue, so plus 2 electrons. So we can cancel out with our 2 electrons that are up here. But before I add them back together and rewrite the equation and stuff, I need to deal with the fact that I've got some H pluses here. And this is in a basic solution. Question 31 says it's a base solution, so we just pretended it was in an acidic solution. Now I have to fix it. I fix it by saying every one of those H pluses is going to get snatched out of solution by an OH minus. How many OH minuses does it take? If I've got 4 H pluses, it takes 4 OH minuses. Good job, A for the day. OH minus 4 OH minuses. If I take 4 H pluses and 4 OH minuses, that's going to give me 4 aguas. That's Spanish class today too, agua, right? And then, since I added 4 OH minuses on the reactant side, algebra says whatever I do to one side, I have to do to the other side, right? We just see we're like the triple threat class. We're learning some algebra, we're learning some Spanish, we're learning some, right? So now my aguas are an issue. I have 4 aguas over. I'm serious, quarantine too long. I can't do this. So I'm going to cancel out dose of my aguas over here. So quattro minus, so I don't know what's the word for minus, subtracto? That seems like I'm just saying stupid things. So I've got 2 waters left over, right? So you can deal with it pretty easily. You just balance it the same way you do normally, and then you deal with the hydroxides. It's pretty common to end up with like a twice half, or like half of your water's in